Hello everybody and welcome back to Chopstick Maths. In this video, we will learn about a few properties of complex numbers. Now, complex numbers, they are in three forms. One is the Cartesian, where z is equal to x plus iy. In the polar form, z is equal to r cos theta plus I sin theta. And the third form, which is known as the exponential form, which is z is equal to r e raised to I sin theta. Now this e is actually called as a Euler's number or as a Euler's constant. So it is a mathematical constant, just like the number pi. Okay. So when I say pi, what comes into your mind is 3.14. So when I say e, what should come into your mind is 2.71. That is the value of this number. Of course, it's a never-ending number because it's an irrational number. Okay, so this number does not terminate. Okay, it is never-ending. However, we round it to 2.71. So, the exponential form is r e raised to I theta, where r and theta, r is the magnitude and theta is the argument. Also in polar, r is the magnitude, theta is the argument, and here this is the x coordinate, that is the real, and y is the imaginary part of the Cartesian form of the complex number. So these are the three forms. Now, let us see the conjugate of the number. So the conjugate of the number z is equal to x plus iy will be z is equal to x minus iy. In the Cartesian form, z is r cos theta minus I sin theta in the polar form, and z is equal to r e raised to minus I theta, that is in the exponential form. So we have seen the number z is equal to x plus iy in all the three forms, and its conjugate z is equal to x minus iy, okay, in all the three forms. Now, if you are taking product of any two complex numbers, then it would be best that you convert it into polar form. Because if you convert it into polar form, multiplication becomes very easy. Now imagine z1 is equal to r1 cos theta plus I sin theta, and z2 is r2 into cos phi plus I sin phi. These are the two different complex numbers. So if you see they are different numbers, so r1 and r2 is not the same and the angle is not the same. One has the angle theta, another one has the angle phi. So we are taking the product now, z1 into z2, that is r cos theta plus I sin theta into r2 cos phi plus I sin phi, that is the second number. Now just take the product of r1, r2 and just add the arguments. So the arguments will just get added, cos theta plus phi plus I sin theta plus phi. That is the product. Now same way when you are taking division. When you want to divide z1 by z2, that is you are dividing the complex number z1 by z2, you write z1, that is r1 cos theta plus I sin theta upon r2 cos phi plus I sin phi. So this is the dividend and this is the divisor. Now again it's very simple because actually now in multiplication it gets added, but whereas in division it just gets subtracted. So just subtract theta minus phi. So r1 by r2, this is the magnitude which will remain here outside, and here inside the arguments will get subtracted. So cos theta minus phi plus I sin theta minus phi. Now in the same way, we can take product of two complex numbers by expressing them in the exponential form. So z1 is r1 e raised to I theta, that is the exponential form of the first number. z2 is r2 e raised to I phi, that is the second number. Now here I am taking the product z1 into z2. I will multiply their magnitudes together. Z1 into Z2, e raised to I theta, that's the exponential part, into e raised to I phi. So again, R1 into R2, e raised to I theta plus phi. So again here, their arguments get added. Okay, arguments, they get added. Now, while taking the product, the arguments will add. Now, let us divide the two complex numbers z1 by z2. So, z1 is r1 e raised to I theta and z2 is r2 e raised to I phi. So, this would be r1 by r2 e raised to I theta minus I phi. So, here I will be taking the I common, that is theta minus phi. So, again you are subtracting the arguments while you are dividing. So, this is the way you can also convert a number into an exponential form and conveniently take their product and also take their quotient. Thank you very much.